acronym that, like many government agency names, is a little intimidating. It stands for Genetically Modified Organism, which contains no words under 3 syllables and sounds very technical. If we're splitting hairs, many things are genetically modified organisms, created by many generations of selective breeding. However, to prevent confusion, GMO only refers to organisms with genes that can't be achieved by selective breeding without taking random mutations into account. Things like tomatoes with fish genes to help them survive winter and bacteria with jellyfish genes that produce colorful glowing proteins are all GMO. What do GMOs do? They serve many functions. The first GMO to be FDA approved was bacteria that produce human insulin, an invention that improves millions of people's lives. Some of the best known GMOs are Roundup Ready crops, which cannot be killed by the common weed killer Roundup. Another common modification is to have a crop produce Bt toxin, which kills insect larvae with such a high degree of specificity that only certain species of insects are harmed. Mice can eat massive quantities of Bt toxin without any short or long-term damage, but it kills many insects that are responsible for killing crops. Other GMOs being tested include wheat that causes fewer allergies, pineapples that produce lycopene, and crops that can grow in salty soil. All these innovations are made in one of 2 ways. Some of the earliest genetically modified plants were made with the gene gun, a device that shoots DNA-coated metal particles into the seed or plant cutting. Modern genetic engineering uses harmless bacteria or viruses that can be used to modify plants. The desired gene is inserted into a plasmid, or a ring-shaped piece of DNA that a bacterium can pick up and incorporate into its own genome. The microbe then infects a seed or plant cutting and inserts the necessary gene into the plant's genome. This process only uses harmless microbes and has never been shown to cause disease. Of course, the plants would be grown and reproduce normally after the first batch. Given that DNA wasn't discovered until 1953, and we're learning more about it every day, GMOs come with all sorts of myths. One famous one is from a redacted study, Seralini and others, saying that GM corn causes tumors in rats. However, the study used rats already prone to tumors, and tumor formation was not dependent on the dose of GM corn given. That and a small sample size of more treated rats than control rats suggests that the tumors were coincidental. Despite being thoroughly debunked by multiple sources, this study is often one of the main sources cited for anti-GMO pieces. That being said, this technology comes with some unlikely but legitimate risks. The worst case scenario is that an altered metabolic pathway could cause a food crop to produce a toxin. It is also possible that using, for example, the wrong peanut genes could cause allergic reactions to foods that don't contain peanuts but contain peanut genes. Other risks include insects becoming resistant to pesticide-producing plants, and people using more weed killers than necessary because the crops are immune. These issues are why genetically modified foods have a fairly tough regulation process. The EPA requires tests of all plants modified to contain pesticides. The FDA is able to require tests of any GM food that varies significantly from the original. There is also a voluntary consultation process that many companies use for better PR. Tests are carried out to ensure that if any processes are changed, they don't create any harmful products. Allergy tests are also done, and fields are inspected to ensure that GM plants don't escape into the wild or interbreed with conventional varieties. The FDA has a public database of which crops have been approved, containing over 150 GMOs. Unfortunately, nothing can be done yet about insect resistance to in-plant pesticides, since that resistance is a feature of evolution and happens in everything from chemical pesticides to antibiotics without any assistance from GMOs. The biggest risks are environmental. For example, some say that GM plants can spread genes for herbicide resistance to weeds, creating superweeds that would take more herbicide to kill. They use the fact that more herbicide is being used on each field now to justify this statement. However, this is a case of correlation and not causation. Just like with pesticide-resistant insects, weeds being killed by herbicide will become resistant whether or not the crops are modified. Another risk is that GMO plants will spread their genes to related species and decrease biodiversity. This is addressed in the regulation process, however, which ensures that GMO fields and conventionally grown fields are kept apart. However, we also have to realize that rejecting GMOs because of the risks of what we have now is throwing the baby out with the bathwater. Most genetic engineering is done by 6 multinational corporations: Monsanto, Syngenta, Dow Chemical Company, Bayer, BASF, and DuPont. These companies, in addition to dominating biotech, make agricultural chemicals like pesticides and herbicides. Because of this, they encourage the use of these chemicals because it makes them money. However, we are seeing the beginning of a new generation of GMOs. In 2014, Aqua Advantage salmon was approved by the FDA after a 25-year testing process. The salmon is modified to grow faster and larger than conventional salmon and is just as safe. In addition, it doesn't exacerbate environmental problems, since preventing them from escaping requires them to be grown in an indoor fish farm. The setup is better for the environment than fishing for wild salmon or sea cage farming. This is one of the first of many GM foods created by a startup or small company with the goal of fixing an environmental problem or issue with the food supply. Another product made by a large corporation is golden rice, created by Syngenta to solve the problem of vitamin A deficiency in developing countries. Because it changed the nutritional content of the rice, it is still being approved in Bangladesh and the Philippines. However, this and the Aqua Advantage salmon have become symbols of many scientists' hopes for the future, that genetic engineering could solve some of the difficult problems facing the world today. Real risks and real benefits, which one outweighs the other? Most say the risks, due to scare tactics used by everything from news companies to Facebook memes. However, if we let these risks control us, we'll never get the plants that can grow in dry conditions or bacteria that can produce previously expensive chemicals. What we need to do is proceed with caution. We must continue long-term studies, make regulation mandatory, and continue to find solutions to the problems of pesticide and herbicide resistance. However, we must not stop the science of GMOs. Biotechnology startups are behind many of the advances that will help people, even if most of their products are still being tested. In addition, we'll be seeing even more startups soon, since the equipment necessary to get started is becoming cheaper and more accessible. Fear of genetic engineering threatens to reverse the tide, with few willing to fund companies making important advances. However, what should really be feared are corporations that make profits off increased herbicide use, as opposed to the startup trying to fix a nutrient deficiency. This technology shows promise in ending hunger, or bringing diverse crops to previously unfarmable land. If we want to support our 7 billion and growing population in an environmentally sustainable way, genetic engineering will, in the right hands, be an important tool.